Yo, what's up? Welcome back. It's been a while since I've been on here. It's been a few days now. I spent the whole weekend. My girlfriend came down, so I had a really great time. Went and saw some friends, but we're back at it. It's Monday. Our website, not LinkedIn. We want to go on Leetcode. This video is probably going to be a bit of a shorter one. Since I've been gone for the whole weekend, I have a lot of stuff to catch up on. So I'm going to attempt to do a few problems now. My buddy's coming over because I got to go to something tonight. Probably record a little bit later in the night as well. Do some sort of video or some sort of probably one problem or something and then call it. But we'll be totally back at it coming in Tuesday. So let me think here. Let's take a look at our Pokemon of the day. We're at 105. We got a Marowak, the evolution. Take a look at the sound. Whoa. Whoa. There's our sound of the day. We're going to skip out on the quote of the day. We're going to just get into some problems because I think my buddy's going to be here in about half an hour. I just want to get as many as I can done. We'll get started at least. Let's take a look at Leetcode. I believe we finished on Friday. We finished on doing these two, but I don't think we actually did them. So I think what we'll do is we'll go back to that. And we'll take a look again. Let's do that. Let's go back. Let's take a look. 1 DP. I think it was climbing stairs. Climbing stairs. Okay, yeah, let's see kind of where we're at with this. We're building the recursive problem here. We got our count, we got our recursive function, we got our base case, right? Which I think is correct because we can only step once or twice, right? So if we're at 0, we would just return the count. If we're at 1, there's only one way that we can go, right? We can either go one step, right? So we can do count plus recursive I minus 1 until we get to the base case, right? If we're at 2 or more, we can either go 1 or we can go 2. If n is equal to 0, I think it's if I. Maybe that's why it's not working here. Missing one argument count. I don't think it would be count plus. I think it would be recursive. I minus 1. Count plus 1. Maximum recursion depth exceeded. So it's maximum recursion depth exceeded. We're not getting to this base case, right? So could maybe I be, if I is less than or equal. No. Yes, I'm not sure why we're not getting the I don't know what the issue is. Wrong use of count parameter, you're processing count recursion and trying to accumulate it, but that's not how the classic recursion of this problem works. If n is greater than 0. If I is equal to 0, return count. We can just return. If I is equal to 1, we don't need that apparently. If I is less than 0, we return 0. The fuck is this? Get rid of that. What is going on here, dude? No outlook, buddy. Apparently we don't need the count in here. Recursive I minus 1, get rid of the count. It's recursive I minus 2. Whoops. Need to wait a little bit. Okay, so we just pretty much didn't need the count and it worked, so alright. It's not gonna submit because we need to add DP, right? It's too slow. So I think to speed this up, we would add we would add some sort of like hash map or something, but I don't know what we'd add in the hash map. That's the thing. Cache to store the results of function calls. Preventing redundant calculations is typically done by adding a check to see if the function input has already been seen, and if so, returning the cache result instead of recalculating. Okay, yeah, I kind of knew that already, but okay, so it looks like here, if n is MIMO, return MIMO n. If n is less than 1, return n. Okay. How can we add MIMO to this? I feel like obviously it would be a hash map, but I don't understand what I'd be storing here because we're going from top to bottom. So when are we ever going to re-see it again? That's the thing. Store the results of the function calls in a dictionary next time. So I'll look it up. Create a dictionary. Before computer requested, check if I is in MIMO. If yes, return MIMO I. If no, computer and store the result in MIMO I. Okay, so let's do, okay, well, if, if I in MIMO, wait, what did we call it? If I in count, we can get rid of this count. Return count I. Else, do we store it in the MIMO? Count is equal to count I is equal to this. I think we need this else, dude, to be honest. I think we can just do this. But instead we return count I. Right? Okay. Okay. So we added memoization. I is equal to 0. I is less than 0. If I in count, we return count I. Otherwise, we call the recursive function here and we find count I is equal to recursive I minus 1, blah, blah, blah. Okay, I'm curious, what's the difference between 1 dp and 2 dp? Let's do recursive. Okay, bro. Okay. Okay, let's take a look at main cost climbing stairs. This is gonna be good because we're doing recursive problems, so we're thinking about them. So you know, it's good. We're getting there, right? Like, next topic will be 2DP, do some bit manipulation. You know, touching on everything. So, let's take a look at main cost climbing stairs. Main cost climbing stairs. We've never done this one. Interesting. Surprised we haven't. You're given an integer array cost for cost size, a cost of the ith step on a staircase. Once you pay the cost, you can either climb 1 or 2 steps. You can either start from the step with index 0 or step with index 1. You can either start the step with index 0 or the step with index 1. I think this is kind of a bad test case. You start at index 0, pay 1, and climb 2 steps to reach index 2, right? So now we're at pay 1, climb to reach index 6. So 0, 2, 4, 6, 7, 9, pay 1 and climb 1 to reach the top. The total cost is 6. Okay, so def recursion. Probably want some sort of I, right? So I probably we need a base case, obviously. So I think our base case would be if we get to the end, right? So that's when we need to stop. So if our I is greater than the length of cost, right, then we can just return. One second. I will be back in 1 second. Yo, what's up, guys? We're back. Sorry, you can see that it's nighttime now. I ended up going and doing all my stuff, so I'm gonna finish off this question here because it's getting late today. I'll be back at it tomorrow with definitely a longer video. So let's keep going at this. Cost size, the cost of the ith step on a staircase on 2 steps. Okay, so we got an array. Okay. We need to return the minimum cost. Okay, we just want to return probably the cost, right? Maybe we want to pass in the actual cost this time, right? So we actually need to add the count, right? Because technically it could start from... You would start at index 1. Start at index 0. You can start at 0 or 1. Okay. So... Maybe can we call it twice, right? So we can call, well... recursion... Our I being 1 and our cost being currently 0, right? I guess we can call our recursion 0 and 1. We want to return count, right? So this count is equal to 0. Cost plus equal to cost I. Then we need our recursive step, right? So we would return, well... Would that work though? I was thinking doing recursion plus I to go to the next one, but I don't think that would work. Plus equal to I. See, I was thinking something like recursion, like I plus 1 cost plus recursion, like I plus 2 cost. But I don't think that would work, right? Because we're adding them together. I don't really want to add them together. Or can we take the min? Or could we do something like... Could we do something like the min of all of them? Like something like this. Because technically we can either go I plus 1 or I plus 2. So technically I think the min would probably work. Unknown network error. Need to log in again, bro. Let's see what this thinks. I don't think this is probably the best way to do it. I don't think, but oh, sorry, not the length of cost. Oh shit, we got cost in here. I wish it should be I guess it could be count instead of cost. Put it on me. So we were right with the cost. We were kind of close. We're thinking about it right. Right, we're using the count here. We got the base case correct. The cost. Technically it should be equal to, we can return count, cost plus equal to count, return min, recursion, I plus 1, count, recursion I plus 2, count. The return account is not valid for the expected return integer. Return count. Let's do x1, x2. Guess we can return the min of x1, x2. Guess we could have just done. I guess that works anyway. Now we need to add we need to add some memorization, right? I would assume here we'd probably use some sort of like hash map, right? My dictionary is equal to this, right? I don't know what the memorization would be, dude. Okay, so we got the base case, we got the cost, we got this. If I count in my dictionary, Okay. Okay, we have our base case. Alright, we don't need count anymore. Get rid of this. Get rid of this. Recursion. No, sorry. What is it called? Cost I. Cost I, then we do the recursion here. Let me know. It's a good problem. But okay, we're gonna call it there. I know that's probably the shortest video we've ever done, but I appreciate you guys watching, and I will see you tomorrow.